All right, find the area bounded by y equals e to the x plus e to the negative x divided by 2 and y equals 2 cosine of the quantity x minus pi over 4. So what we're going to do here, since we're dealing with an exponential sum of exponential, and really we don't know this yet, but this is actually called the hyperbolic cosine. And then we have a trig function, so we're going to have to use our calculator. The way we're going to do this is type it in. Now you have to be careful about making sure you have the right number of parentheses for the 83, 84s. So we start with a parenthesis, e to the x plus e to the negative x, and then close both of those, divide by 2, and then 2 cosine of x minus pi over 4. Make sure you're in the right mode as well, that you're in radian mode. Now we hit graph. Actually, I already graphed this. And if I would have hit zoom 6, let's see what that shows. You can see that these things cross, but it is not really clear at this point. So what we could do is hit zoom 4, where it says z decimal, and you can get a nicer picture there. So let's sketch this graph. And we have and then this one will come in. And that's not a particularly good sketch, but that'll work for what we need. Now the first thing we're going to do is draw our element. This will be vertical. Label the thickness of the element. It is along the x-axis, so it's delta x. Now what we need to do is find these intersection points. So I have my curve, and we'll press second calc, find intersect, so that's 5. First curve, just hit enter. We only have 2 curves in there right now. Hit enter again, and move it a little close to the number, and we get this number that says negative 0.244, comma 1.30. 1.030. Now we're going to want the x values, since we're going to be summing up along the x-axis, and we need to keep this number. We need to keep all these decimals, and you have the question written down. So let me move this up and so you can see the keys as well. What we want to do is go to our home screen, second quit, and we have this value right now is stored in at x. So if you press x, enter, it gives us that number. And that number is a little bit hard to see. Let me see if I can move this over a little. And what we want to do right now is hit stow. We want to store that number into a letter. How about A? Now, I can put on my paper a little thought box and put A. I never want to use that A when I'm actually setting up my integral. I'm going to use the values there. Now we're going to go ahead and find this one. So we come back to our graph, and we'll do second calc 5 again. First curve, enter. Second curve, enter. This time it's over here somewhere about 1 point something. You could say 1.2. And that number is 1.209, rounded to 3 decimal places, comma 1.824. Now let's store that number. We can go back to our home screen. Second, quit. And we know that's the value stored in x, so we can just say x stow alpha b. Now every time that cursor moves on the graph, the x value changes, which is why we want to store it into some other place other than x. Now we can set up our integral, and our integral is from this negative 0.244 up until 1.209 of what? What is our top graph there? That top graph is 2 cosine of x minus pi over 4 minus the bottom graph, e to the x plus e to the negative x, all divided by 2, and then we'll close that, multiply it by the thickness of each rectangle, and we'll get our area. So we have area is going to be the top minus the bottom times its thickness, which becomes our dx when we sum it all up. Now we can integrate this, find the antiderivative of these two functions, but since we have these decimals, we don't want to even consider doing this by hand. Let's just type it all in on the calculator, and then we'll just write the answer down. Note what we're going to do is use our calculator, but we're not going to write our calculator notation at all. So how do we do this on our calculator? We go math 9 to give our fn int, and then we have to say, where did we put this 2 cosine of x minus pi over 4? Let's take a quick look. That's at y2. So let's go back to our home screen, and we press vars, and then it says y vars at the top. That's our y variables. Move it over. We're dealing with a function. Hit enter. And the cosine was in y2, so we press y2. Minus, repeat this process, vars, y vars, function. And then we want y1, so we can just press enter. And then we want to put comma. What are we going to integrate with respect to? X. Pretty much always on the 83, 84, that's what you're doing. What is our lower limit? Alpha A, comma, and our upper limit is alpha B. We can close that parenthesis, hit enter, wait until it comes up. That wasn't too bad. And we get approximately 0.764 square units. And pretty much all of them are going to be similar to this when you have to use your calculator. And that's it for the TI-83, 84s, and I'll show a next one for the 89s.